Good afternoon, ladies and gentlemen. Welcome to the Future of AI in Maintenance Engineering panel discussion, which were generated on the back of our performance and focus research that we did for the second year running in conjunction with the Institute of Mechanical Engineers. If any of you who's not had a chance to read it yet, you can find a link to that in the chat. My name is Richard Jeffers. I'm the Solutions and Technical Director for RS in the UK, with a background in maintenance and operations management. And I'm joined by three luminaries from the world of maintenance and AI today, and indeed three colleagues and friends outside of this table as well, Jonathan, Rob and Agajan. So, Jonathan, do you want to introduce yourself?
Yeah, Jonathan Bedell. I'm the head of maintenance at Bentley Motors, and we are very much in the AI transformation.
Thanks so much.
Yeah, hi, Rob Russell. I'm from Siemens. I'm the head of predictive maintenance strategy and delivery for a product called Sensei.
Yeah, thank you very much, Richard. I'm Agajan Torayev, co-founder and CEO of Robominder, startup based in London. We are developing video analytics solution for manufacturing companies.
Excellent. Thanks so much, guys. Now, there's some questions that I'll be asking the guys over the coming time. There's also an opportunity for anybody to put their own questions in the comments section of the event, and we'll come on to those towards the end of the conversation. So we're going to talk about six main themes today. First of all is around predictive maintenance, moving into workforce support and skills development, then asset management as a broader topic, digital twins, and finishing off with something that many of us probably find slightly intimidating, cybersecurity. So I'm going to start off with Rob and your expertise around predictive maintenance, Rob. 38% of companies were surveyed have a predictive maintenance strategy in place, significant behind the percentage of people with a planned or reactive strategy in place. With many engineers currently focusing on fixing what's happening and responding to problems in the now, how can AI prove itself valuable and prove itself valuable enough to justify the investment that companies spend on it?
Yeah, so I think it's justifying that spend. It's obviously looking for how do you justify the return on investment, and how do you get that in a short enough time frame that you can actually push that through and demonstrate, more enhancements on that spend. So it's not necessarily going for like a big bang approach to covering the entire factory. What we find is clients start out with what we call initial deployments, maybe somewhere between 50 to 100 assets to try and get that evidence that they need to understand how the technology will work for them. And I sort of pitch the fact that you're not going in to do a proof of concept of the technology. What you're trying to do is see how can you adapt your culture and behavior within your organization to make best use of the technology. But right from the very beginning, you want to focus on where you're going to get maximum business impact. Because if you're trying to prove something in 3, 6 or 12 months time, Jonathan will tell me his machines don't fail every day and every week, right? So you need a bit of chance in here that something's going to go wrong to give you that evidence. So you actually use a data-driven approach to find where's the best place to apply the technology, first of all, to see the benefits. And those benefits, I think, go beyond financial benefits as well. There's a lot of focus on cost of downtime. We'll maybe talk about that in a bit. But also keep in mind, finding failures early, you're avoiding secondary damage. You're replacing components rather than having whole machines become, damaged and have to be replaced entirely. And there's also impacts on other areas like energy consumption and sustainability benefits. This is one of the key things that we're sort of promoting with a predictive maintenance strategy is the impact on sustainability. If you're doing less maintenance less often, using fewer consumable parts, and making components last longer, they've all got a massive impact on sustainability.
A lot of those topics resonate, a lot with me, Rob, from my time as a group engineering director. Certainly, that concept of changing the component before it fails and avoiding the ancillary damage is really important. And criticality drives everything in a maintenance world. So understanding your critical assets and focusing all your energy there rather than dissipating them across the thousands of assets across your factory. Jonathan, I've been to your site. It takes absolutely ages to walk from one side to the other. It is definitely a large factory. Anything to sort of add and build on Rob's point?
Yeah, I think just really building on Rob's point, although obviously Rob doesn't, talk about things as proof of concepts, I think, there will always be a proof of concept that needs to be justifiable to finance. So there has to be something tangible to the bottom line. And that can be quite difficult, I think, for some businesses. We are quite lucky, as most maintenance departments are. So they have talent, they have the ability to develop and run very small projects in a sleepy corner of a factory to actually prove the technology. And, we're really blessed that there are, huge myriads of technology that's available at people's fingertips now. And a good chunk of that is deliverable by the teams that are in-house with the support of obviously larger companies. So I would say, absolutely, it's about looking at the assets that are causing you problems, focusing on those, seeing what pieces of technology are out there, because a lot of it will come down to you home growing kind of a solution before you can then go forward and actually try and generate the kind of business case that a finance department would want to see. AI is particularly difficult, very difficult for finance departments to understand, because technically we maintain facilities every day and we meet the metrics we achieve. So why would we want to do anything differently? So definitely, I think, it is about having something tangible on premises that you can demonstrate. Yeah, there's a real need to do that.
I think one of the things for me in this area is you've also got to recognise that if you apply AI to an immature maintenance organisation, then you just spend money and get no value. You need to be doing the basics well. You need to be doing your cleaning, your inspection, your lubrication, your tightening activities, that basic asset care. Without those fundamentals in place, everything else as you move up the maintenance maturity pyramid is built on sand, and therefore is ultimately going to fail. Agajan, anything to add to that one?
Maybe I can add a couple of sentences on top of what Robin said. So I think the challenges here, like using AI algorithms, require a lot of data, and predictive maintenance is inherently data hungry. So the companies who invest maybe 10, 20 years ago in data collection and data storing are seeing the benefits of using the predictive maintenance. So that's why I would say why reactive maintenance is still preferred rather than predictive maintenance, just purely because of the data.
Yeah, and that data piece, of course, is critical. You need to be having the right relevant leading indicators of failure collected at a cost-efficient manner before you can feed it into the algorithms.
Yeah. It's building on that digital journey, digital maturity. That's key. That's fundamental. Yeah.
So moving on to one of the other areas that we found in the research around workforce support. So attracting and retaining talent is highlighted as the biggest challenge in the 2024 maintenance engineering report. And indeed, I was hosting a roundtable event on the same topic about 4 or 6 weeks ago, and I think for my entire career, attracting and retaining talent has been a significant challenge within a maintenance and engineering space. I don't see it as being a new issue for 2024. I think it's been an ongoing issue for my entire working career. But we've got some more tools to try and address those challenges now. And so Jonathan, I know you invest heavily in early careers activity at Bentley. How can AI support talent retention or help to fill the gap of staff shortages?
Yeah. One thing I would say is I don't think right now AI does a direct replacement for some of the skill sets that we have. If anything, it gives us a little bit more of a problem because we obviously know we have a skill shortage in this area, and to the point that we have to fundamentally change the type of apprenticeship program that we offer now. So for the first time, we have data science apprenticeships, so degree-based apprenticeships inside maintenance at Bentley. Whereas the traditional would, of course, be the standard mech-elect type roles. I would definitely say that certainly the skill sets of the older generation are still very, very valid, but perhaps the prevalence of it isn't as valid. So the amount of equipment is very heavily mechanically based, or runs on very old gen kind of inverters, drive technology. This is the type of stuff that is now only maybe 20% prevalent in a future factory. Versus, say, the traditional factory where at least 80% of it had some form of mechanical kind of oversight. So I think they have to coexist. What that exactly looks like, I think is still kind of, we're a bit unsure. Maintenance departments are probably closer to IT departments now than they've ever been in terms of skill set.
Yeah. And we see a lot of that kind of blurring of that IT line.
Yeah.
It's completely blurred now. There's some distinction.
Yeah, and we still find, when we talk to our customers that actually, you need to blur that line. But then, sadly, in many organisations, we still see some very high walls built between the OT world and the IT world. Indeed, where the maintenance world looking after the operation technology, don't even know who their internal stakeholders are in IT. But actually, if you're going to drive value out of data and drive value out of any form of analytics, you've got to, as Rob said, bring those two worlds together and address some of the cultural challenges that exist there. In an OT world, change is bad. In an IT world, legacy is bad. And so there's some fundamental behavioural issues there. Agajan, anything from your perspective on this in this area?
Yeah, I think with AI, shift with the younger generation is towards data analysis, data science, as Jonathan said, more machine learning, and interpreting the results. But there is also very high risk. So, if you don't understand the fundamentals, then you can probably interpret the data wrong way. And I would say it should go hand in hand together. But at the same time, we should also think about how we capture the knowledge from the old generation, how we capture this knowledge and combine it with AI-based things.
Yeah, interesting.
I'm convinced that there are some really exciting opportunities that will emerge in the maintenance world around generative AI. And actually, if you think about all the textual-based information you have in a maintenance world, whether it's the OEM manual, whether it's your spare part list, whether it's all that amazingly rich data in the CMS platform, where everybody's diligently put in what they did on the back of that work order, and I can see generative AI giving an opportunity to start to actually mine that insight. Yeah. I come from a very high maturity lean manufacturing background with a really strong A3 problem solving mindset. But the problem with that, even in that organisation, you do the A3 problem solving, you build out your follow up table and you put your countermeasures in place. But then a year down the line, everybody's lost that sheet of A3 paper. But I think in a future state with that insight built into a large language model, suddenly that becomes corporate understanding rather than just something on an A3 paper.
Yeah, and that's a sort of flip that we're made recently. It's quite obviously really for us what's happened over the last couple of years and the focus. We feel we've kind of cracked the time series data AI type of problem now. And we've been integrated into maintenance systems. We've got lots of interaction and feedback from users. And like you say, it's leveraging that now. And this is where the Gen AI is providing that capability. But I think back to your kind of comment, Jonathan, as well, about the use of AI and with the teams and the skill levels. The way that we think about it a lot is actually you hide a lot of that complexity away. Most of these individuals that are going in to do maintenance, they want to get their hands on some tools and actually get on and fix an actual physical problem. We don't believe, maybe we're wrong, that they want to actually start having to think about algorithms and anomaly detections and learning data sets, and solving those type of problems. You want to just give them the result.
Yeah.
But a big part of it as well is with that result, what do they do, right? And with the Gen AI stuff, we've got some concerns in the way that we're going, where it's starting to move very much into a prescriptive world. But that Gen AI doesn't know who it's talking to. Doesn't know if it's talking to a machine operator that's qualified to operate the machine, or is it talking to a technician that's qualified to open the back of the machine, right? So you have to be very, very careful about how some of this new knowledge and information follows itself up within this technology and who's going to make use of it.
And that question of the skill of asking a question, I think become even more relevant in a Gen AI world. Was it Einstein who said, if I had an hour to save the world, I'd spend 59 minutes working out the problem statement and then 1 minute saving the world. I think that becomes even more relevant in a world where all the information's there.
Yeah.
You've got to have the skill to ask the right question. Agajan, Rob talked about time series data being, moving towards being a solved problem. We've touched on textual data, but you focus on video. So, what about AI and video?
So humans inherently see world with eyes. They try to understand physical properties, everything that's thinking. So it's eyes our like primary source of information. And what I personally think that should be true for AI as well. We need to teach AI and specifically manufacturing domains how the processes happen throughout the time, not only the underlying, the time series data, but also visually why this is happening. Then once we have this visual data, then we can probably start asking different types of questions rather than textual questions. So we can also put some alarms on visual data. So I truly believe that video data will be the next big thing, and especially for manufacturing, because the currently existing systems, especially ChatGPT or other which tackle with the images and video, they are very generic. Unfortunately, we need to train models for manufacturing so we can utilize it in a more efficient way.
We were having a really interesting conversation the other day, Agajan, about some of the GDPR and personal, identity issues with video. You don't see that in a stream of telemetry figures, but actually it's very real in a video. Do you want to, what do you see as the challenge, and what are you guys doing to address those concerns from manufacturers?
Yeah, obviously GDPR is a big challenge, so we need to validate the privacy of operators of the stuff. So Robominder, we take this very seriously, and we blur or cut out every personal identifiable information. And to be honest, AI doesn't need to know the person; it just needs to know the concept of the person, or the concept of the parcel, the concept of the address. It does not need to know the fine-grained details where this parcel goes to, or which operator acted in this way. So yeah, I think we can do it. We can train AI models purely on anonymized data.
Okay, that's really interesting. Certainly, when you shared that with me, I was like, I hadn't thought about it in advance, but the minute you said it, it was like, wow, that is clearly a significant problem, and it was, very informative to me to hear how you'd addressed it within Robominder. So AI is clearly a big thing, and we've got some data savvy, youngsters coming through the ranks, people coming out of university and degree apprenticeships, as you said. But actually, there's a lot of people in the older generation, so who need to come to terms with this. But also, we've got all those, traditional skills within the older generation that need to be merged with the emerging skills. So, Agajan, what are the risks that we lose some of those skills learned by the older generation and we don't capture that with the new talent coming through?
So, as Rob also mentioned, with AI, we're abstracting a lot of things, right? And we are in the risk of losing practical aspects of maintaining something. Right? So I would say, unless we capture this knowledge in a much better way than we do it at the moment, we have a huge risk of not being able to manufacture certain types of products.
And I would add to that as well. It's back to your point about having access now to maintenance records and things like this. In effect, you've got people that are moving around computers a lot more now. If you think of, you had that worker that had been in the factory for 30 years and could just walk down the line and hear something going wrong, right? That typical
screwed up
analysis. Yeah. In effect, the technology becomes that. The technology is the thing that's at the core and will be there for years and decades to come. And it's potentially access to 10 years worth of maintenance records for that production line. And you can quickly parse that, simplify, and pull it back to your younger type of user that's not wanting to sit in the same job for a decade. It's quite unusual nowadays, I would say.
Yeah, I think for me, one of the really important things about AI, I'm a big believer in the use of AI in maintenance. That's the reason I'm here today, and I'm really excited about the opportunities. But for me, it's never going to replace the core understanding of how machines operate. If you don't have that intimate understanding of the working principles of an asset, then actually the insight doesn't bring you anything. Because like any other technology, or even doing a calculation on a calculator as opposed to pen and paper, you need to know the order of magnitude. Yeah. You need to be able to know I'm in the right place, because otherwise you've got no opportunity to sense check the outcome, and then you suddenly start driving down that one-way street that Google's pointing you down when it's quite vaguely not the right thing. And for me, that's even more relevant in an operations and maintenance environment. You've got to, we need our maintenance professionals to understand the fundamentals of reliability, of failure, reliability center maintenance, etc., and then the AI becomes a massive force multiplier. But without understanding how the machine operates in the first place, the AI is just tech on top of.
It's a fundamental basic, isn't it? So the maintenance colleague is effectively the toolkit. They are skilled, capable. They obviously know what they can and they can't touch. The AI is a bolt-on. It's something that obviously assists them. And I guess the question longer term will be, will there be different functions within a maintenance function? So, I think you kind of alluded to the, it's a steerer. It's something that steers people in a certain direction. And it's really about making sure we've got the people that understand the AI and the algorithms in the background. But at the same time, we've got to educate all of our shop floor teams as to how they use that and what they do with that data.
Yeah, and very much it's back to that sort of force multiplier. It's amplifying, it's scaling the human. That's what I always say about the technology that you implement.
Yeah.
And in some cases, it's we used to talk a lot about maintenance heroes, right? And it would be there's something go wrong in the line, and you get somebody that's sprinting down with his toolbox, and he's the guy that's all of a sudden, with the use of this type of technology, you've got these hidden heroes, right? Because they're on top of it all, right? And you're not seen as like one that's saving the day and got the line back up and running because the line never stopped, right? But you need that recognition that you get into that stage and you're still recognised as a maintenance hero, right? For keeping on top of it, using the right tech to achieve the company's outcomes and business objectives.
Yeah. You've got a great tagline within Sensei PDM, Rob, with predictive maintenance at scale, because we can all look at one set of telemetry and know that it's a leading indicator of failure, but you can't look at 10,000 telemetry feeds and do it. So that always resonates when you talk about that scaling issue. So moving on to another topic now. This is around aging assets, and from the insight in the report, the biggest single cause of unscheduled downtime was called out as being aging assets. And this is a topic that we were talking about actually before the webinar started. So, Jonathan, A, do you have any aging assets in your factory? And B, how do you see technology supporting those aging assets? Or indeed, is it a new problem? Are we really seeing a new problem with aging assets, or is it the old problem?
I don't think so. I think it's still the old problem. But I think if you compare a proper aged asset to a state-of-the-art piece of equipment, it's really the only difference is that one of them tells you something is wrong with it and gives you an indication where to go look. So if you can employ pieces of technology that you can bolt on afterwards, you effectively make something that is dumb smart, and you can start pulling together the data. You can start pushing that into algorithms to talk about the number of cycles, for example, a press has run, how many times has a certain push button been pressed, what's the uptime of that piece of equipment, the temperature, the humidity within a certain cabinet, whatever it may be. And we're really blessed that we can do that kind of thing now reasonably cheaply and efficiently. The beauty of Industry 4 solutions are that they talk to other Industry 4 solutions. So we can bolt on, and we have bolted on some in the region of 300 individual sensors on some of our key assets. What we've done with that data is not only use it in its proprietary system, but we've also pushed that into a cloud-based solution with AWS and developed for 1.5 years an algorithm that allows us to start, predicting a point of failure. And all of this has come from that kind of data that we've collected. When we first went on the journey and began implementing these sensors, we didn't really have the vision that we were actually going to start developing our own predictive algorithms. So this is where the technology has moved on at the same rate, obviously, as we've been implementing sensors, and suddenly another opportunity has presented itself, but it all came back to collecting that data. So initially it did something for us. It allowed us to get transparency of machinery that ordinarily wasn't connected, and now it allows us to push it into same data, push it into a model that then gives us even a date and a time in the future where we predict it's going to fail. So, yeah, we do.
Yeah. I think that the whole question of aging assets is one that, I always find interesting. My background's in brewing, and I had, assets in the 50s, sometimes the 1850s, that we were using, very effectively to produce, well-known consumer brands, but those assets have been cared for. I was reading an article about the B-52 airplane the other day, which is now scheduled to be in service for 100 years. So if you can keep an airplane in the air for 100 years, then surely you can keep a production line going for 100 years. So I don't know, Agajan, any thoughts from you on how people should manage the challenge of aging assets?
Yeah, I haven't worked a lot with aging assets. The only aging asset I work with are robot controllers. I had a chance to work on brand of robot controllers, and the challenge was still the code base was written in 1780s, and the challenge was integrating with predictive and AI algorithms. And we kind of needed to develop this kind of middleware where we can try to connect modern solutions, modern AI algorithms, let's say, with the old robot controller and extracting the data. I cannot say that's an easy task, but still possible with some kind of sensors, with some kind of hacking around with control.
And I think, for me, that resonates, the fact that, people aren't going to suddenly replace all their assets, because they want to have an Industry 4 factory. We don't have that much CapEx or indeed that much management bandwidth. What you need to do is think about how you modernize, regenerate, keep up to date your assets and fundamentally love them and care for them. Rob, anything to go on to that?
No, I'd just say what's been interesting, it was part of our journey of becoming integrated into the Siemens business 2 years ago, starting to really recognize this retrofitting that's going on. And there's a whole sort of concept there that's been pushed of brownfield connectivity, having gateways, boxes that can be added on as edge devices that support all of those legacy protocols, and then can start to convert those through into digital signatures, I think you're achieving, pulling data up into the cloud. But it's a recognized focus, because it's not, when you talked about maybe industrial internet things a few years ago, you think it takes, if you were just going to do it through the upgrading and the changing of new assets, it would take decades. So retrofitting is a huge aspect of that.
Great.
So just because people are sitting there with older assets and maybe not an asset replacement on their CapEx plan doesn't stop them taking advantage of these emerging technologies. You just need to think about, that retrofitting piece.
Yeah. And as we were talking about earlier, the kind of CapEx part of it, this is where, I think when you look at the report, a lot of the people who responded to your survey were mostly technical and management. And I was pointing out that it'd be really nice to see what CFOs thought of this, right? How pleased is your CFO if he doesn't have to find a huge CapEx spend next year, and you can keep those machines running for another 5 or 10 years, right?
Yeah, exactly. That certainly resonates from my time when I was in industry of, let's actually think of clever ways to stretch the asset rather than rush out and buy a new one.
Yeah, I agree. It's making sure we sweat the asset, and when we've really sweat that asset, can we kind of refurbish and ever so slightly upgrade that piece of equipment rather than throwing it away. And as you say, it's a cost-conscious world. And for sure, no finance team is going to sign anything off unless there is a real tangible need.
And then back to the sustainability part again, right? Great news.
Yeah, we'll throw it away. Yeah.
Great news.
So we know there's been a lot of stuff in the press about digital twins. I think in my experience, if you ask 10 people a definition of digital twins, you'll get 20 different answers about what a digital twin is. And they've been promoted as providing a really strong foundation for lots and lots of things. Predictive maintenance, one of those, operational efficiencies, improving product flow through. But actually only 57% of our respondents, believe their data is reliable or very reliable. And actually only 19% of our respondents felt they were operating a high level of maturity in the maintenance world. So Rob, what needs to change for organisations' maturity and trust in data to improve? And then, second question, how is this going to impact the introduction of digital twins if we consistently know what a digital twin is?
Yeah, I think it's part of having a longer term vision. It's how you're going to deal with data and your strategy for that. And I think when you start thinking about digital twins, it starts right from the concept of maybe the drawing board, right? Maybe you're wanting to implement a new production line, or maybe even upgrade an existing production line. So you can retrospectively bring in a model of that line, start to understand it, and conduct a lot of experimentation. I'm sure mentally you're doing this, right? You'll be virtually producing the vehicles before you actually physically do it. It reduces all of the cost. But then when you translate that from that design aspect through into the operational phase, one of the big challenges that we face when we're rolling out our systems is just getting access to the metadata, understanding what's the hierarchy or ontology of all the machines in that line. It all exists in all this CAN information and digital information that's been used in the design phase, but it very rarely gets pulled across from design into the operating world. And those digital twins, they shouldn't just be seen as something that is just used for design and then it's frozen once the line's up and running. It should be there for the entire lifetime, all the way through, and it allows you to do more experiments and build on data. And even some of the things we were talking about earlier, like having more context for that information, we're realizing now that even just having information about the make and model of the machine that we're looking at, the difference in output that we can get from our generative AI and the direction that we can give to the end user is massive. Just knowing that if it's a large motor or if it's a variable frequency drive as opposed to a robot or a conveying system, the interpretation of the results is immense, and how these systems work with very little context as well. And I've forgotten the second part of your question.
Well, that was probably the second. That was how is this? So the first part was around what needs to change for organisations' maturity and trust in data to improve, and then the second bit was around how's this going to impact the introduction of digital twins. So you probably covered the second bit.
So strategy, and then just leveraging that data right the way through into the full asset lifecycle.
Yeah. Agajan, you're probably the robotics expert on the chair and sofa today. So anything specific from that field?
Yeah. During my PhD, we discussed a lot about digital twins. So I have mixed feelings about digital twins, where it's really beneficial and where it really needs to improvement. So it's very useful when we're dealing with operations. It's a light balancing, load balancing, or routing, or different kind of operational research kind of questions. We can build digital twins and simulate and try to understand different scenarios, different possibilities. The challenge exists when there is a physical system involved. So imagine just simulating even water droplet or lubricant or oil interaction. This becomes very, very challenging. And during my PhD, I tried to use digital twins for optimizing energy consumption. But what I have in a digital twin is completely different from the real system. Because of these minuscule interactions, vibrations, they change everything. So for organizations to trust even more, I think there is a technological challenge. We need to develop better simulation environments so we can really well replicate real physical assets. So, but I'm very optimistic on that. We'll be there soon, hopefully. Mm-hmm. And it's going to give us a good edge because we can play around with the digital as much as we can without any disruptions or without violating any safety standards.
I think one of the issues for me with digital twins is actually a lot of the hype around it because, I don't know about you guys, but I've been doing simulations of my production assets in Excel and MATLAB for my entire working career. They've suddenly now become called digital twins and they're new. But the reality is, we've been doing this for 4 years. I think my first digital twin was probably done when I was making solder wire, and we worked out that if we reduced the temperature of the atomizing chamber, we'd get more product through. I used to look after 3 large anaerobic wastewater treatment plants, and we had a very large Excel model. I was talking to a colleague of mine a couple of years after, and they bumped it into a more sophisticated model and have managed to reduce the operating cost of that. So I think a lot for me is actually it's been overly hyped up, but actually people are doing this. And they're seeing those challenges, and some systems are inherently chaotic, like you talked about Agajan, which makes it more challenging, and other systems are more simple. Jonathan, anything from your perspective?
Yeah, I think digital twins, we have to remember as well that they've come on a massive journey as well in the last 3 or 4 years. They really started as almost a 3D scan of a production environment, and have almost now become because of technology, like I say, full simulation platforms and dynamic simulation platforms, Joe, the Gen AI inputs into it, you can pretty much run a simulation of where your production environment will be in 30 minutes time from live Gen AI collected data of your existing kind of production landscape. So I think from where they've come to where they're going, I fully agree there is so much more data that potentially could be cohorted into a digital twin. I think going back to kind of yesteryear when simulations, as you say, you could map everything in an Excel spreadsheet pretty much. I think the only thing that the modern digital twins do is they take away a lot of that manual input. They actually use the data. When you're in a Gen AI solution, they use that data to be able to do that predictability, not rely on Richard or John's kind of fingers typing that information in or running a simulation. But yeah, they are an integral part of the production landscape right now.
Yeah.
On the subject of Excel, Rob, how many people export out of Sensor PDM into an Excel spreadsheet?
Oh, I'm not sure. but you have to still work with what people are comfortable with, right? So there's the export to CSV button. If you want, but you might want to take the report for some of those. But at a higher level, all the APIs, you can pull it into Power BI, into your data warehouses, into your Tableau. That's what we're seeing a little bit more of, which is good. Yeah, concepts like line-side dashboards. Even this week, been talking to somebody about taking PDM data and putting it into SCADA systems. Right? Yeah, interesting.
Yeah. So going back to the beginning of the question, the question around trust, in data and data reliability. Obviously, if you've got a telemetry feed, then fantastic. As long as you've calibrated it, then you're going to be getting, accurate data. But actually, how do you get around that challenge of trust in data?
Proof of concept. I think it's proving it through. It's still very, very voodoo. Some of this stuff. It's very, very kind of. Nobody really kind of understands it, and until you see a tangible benefit from it, people are not going to be fully kind of vested in it. It's something good. You know that it will give a return, but not everybody understands exactly the reasons why. And the problem is, when you put it down on a piece of paper, it's a little bit like life insurance. You try and sell life insurance just on a piece of paper, and it seems like a really poor deal. You pay someone money and then when you die, they give it back to you. It sounds terrible on a piece of paper, and AI is just the same. Unless you see it and you live it and you breathe it, it's just, here's some investment in something that will allow me to be a little bit better, but I'm already still achieving my targets.
Yeah. So we used to talk about selling vitamins, which sounds a little bit less morbid.
Oh, yeah.
Yeah, exactly. Yeah, exactly. It is that. And again, it's bringing back the focus to business outcomes. Well, we get questioned a lot. It depends on the scale of sort of maturity of the customer about the precision and the accuracy. And we say, well, the precision and the accuracy comes down to case studies where, like, what is actually the saving? What was the initial investment? How much are we paying for the system do we put in place? And are you seeing 10, 15, 20 times return on that investment on an annual basis? And those are the sort of numbers that you want to sort of focus on. But yeah, right, there has to be a level of confidence in what you're getting, this whole sort of garbage in, garbage out scenario. And, with what we're doing in the Sensei team, I said at the start, I lead our delivery team, and that's a key aspect, is making sure that the customers understand what is the right data to feed. Because there's too much hype out there about AI, machine learning. If you throw enough data, enough CPUs, some magic will happen, right? Some people tell me we're moving into the world of magic with all this generative AI stuff, but we're kind of grown up to know magic doesn't exist. So we do need data that it has meaning to it, has information about the actual state of the asset itself, and it changes with the condition of the asset. So that's fundamental before we even start sending data into algorithms.
Just on the spirit of throw enough data, probably you'll get an answer, some magic will happen. I did read some research the other day that turns out that even if you have an infinite number of monkeys, you will never produce the works of Shakespeare because the universe won't last long enough for it to happen in.
That's good to
Someone's done some great research on that. Agajan, just in terms of data reliability. Telemetry feeds, easy to get a robust set of data, but of course human factor losses, are always more difficult to be confident of understanding it. How does video analytics help people get really reliable data in some of those human factor losses?
Yeah, that's a good question. Actually, human factor losses like performance loss, availability loss, because of the human factors, are inherently difficult to monitor and track because of the privacy reasons. Because you cannot put sensors on people, right, during the manufacturing. So, video analytics can partially solve that problem. So, as I said, we can anonymize operator's person, but we can still capture the pose of the person, the operations happening there. The process of, let's say, we can capture the assembly, the whole process of assembly, which parts needs to go in and what the final product should be. So these all can be captured in a video sequences. Once we capture this, and then we can start analyzing either anomalies happening from one operator to other operator, or we can also even benchmark why the quality of first cell was bad, was worse than the other cell. So in a sense, it's not 100% solution for capturing data, but it's better than nothing. It helps to capture all this critical information that leads to the loss in manufacturing.
Thank you. I'm going to move on to the last of the preset questions, which is the one that we all, put our hands down for in terms of volunteering to answer first. Around cybersecurity, a challenge that many of us are aware of, but probably a lot of us feel that we wish we knew more about than we do. UK manufacturing does face a disproportionately high number of cyber attacks compared to other sectors, especially smaller, organisations. In Agajan, what factors do you think people need to consider around cybersecurity?
Yeah, so when we're talking about cybersecurity, we always think, this highly sophisticated coding happening. Yes, it happens. But did you know that more than 90% of cyber attacks happening because of the social engineering? Someone sending these links, someone sending these files that you don't need to open, or someone impersonating someone else. So with the Gen AI at the moment, it became so easy to impersonate someone, so easy to create this deepfake. So I would say we should probably focus a little bit more on the social engineering aspect of cybersecurity. We should make people more aware that certain people calling you, maybe it's not that person who you think are. So I would stress on that, because almost 70% of data breaches start with a social engineering or phishing attacks.
I know it's something that we take very seriously within our S group, and we all get phishing attacked by our friendly attacker team inside our infestation security team. And I know from my own personal experience, I'm a lot more conscious of it now after 5 years of being constantly attacked by by our friendly infosec team. One of the things that I find when I talk to customers about security is the concept of security by obscurity. We're fine because we're not connected to the internet, but actually, if you look at a lot of the research around this, is people believe that their factory is not connected to the internet, and then you start to dig into it, and you find so many, pirate internet connections of machine X over here connected and machine Y over there connected, and because they're outside of the control of the corporate body, they're actually more they're creating more vulnerabilities if they actually just put a proper IoT connection in. Rob, I know this is a challenge for you guys at Sensei PDM of getting that telemetry data into the system. What issues do you see when you're talking to customers about cybersecurity?
Yeah, it's beneficial now. Being part of Siemens, with security is just inherent in the design of everything. It's been able to pick up these gateways and edge devices that they're secure by design. Fundamentally, it adds a little bit of overhead, right? And there's extra steps that you have to take to get these things set up and put in place. But we've got experience. We're talking to customers that are picking up things that are more for like classroom use, like Raspberry Pis or Arduino kits, and trying to build their own connectivity. I really don't think one of our needs to do that anymore. There's so many off-the-shelf solutions now that you can pick up that are fit for industrial use in the industrial environment. And it's also making sure that you don't layer compromises on top of compromises, right? Because you start to find you open up a gateway to let some port through, or you end up instead of using some formal method or some formal protocol, you're using a username and password to connect a device up to a cloud solution, and then all of a sudden you find that this little pinprick of that you've opened up starts to grow and grow, and people piggyback off the back of it. It becomes a nightmare. So you've got to think about fundamentally security right from the start.
I was in a factory fairly recently. I definitely won't name the customer. They'd not only had they written the password and username on the machine, they'd actually had them etched. As properly etched up, signposts to go on each machines with the username and password for all the PLCs. So yeah, that's what not to do, by the way. Yeah, no, always keep username and password private and never use the standard defaults.
I think one of the absolutely. I think one of the areas that I think manufacturing teams, maintenance teams probably need to be more engaged again is that relationship with the IT functions. And for years and years, IT functions have spent all this time trying to close themselves off and be secure and not to allow cloud entry. And then, of course, we've turned up with probably very limited foresight and said, we need to push everything into the cloud. And you need to give us gateway and access and port forwards and all of these things. So I think a lot of it is that relationship and that awareness of what we're doing with IT teams, because it's a two-way street, and we've accelerated so quickly in the last 5 years in terms of technology on the shop floor that we've probably overtaken in some cases the bandwidth of a lot of the IT functions, and that's our responsibility to manage that relationship.
So that's the end of the sort of 6 discussion topics that we had, pre-agreed. We've got some questions starting to come in from the audience. So the first one we've got is for organisations considering AI in their maintenance strategies. Where should they start? Maybe Rob, you probably have the practical experience of this, of talking to a lot of customers. So
yeah, it's I think you're looking at your maintenance strategy. It's not there's no one aspect to it. People talk about maintenance maturity, moving from reactive to planned to predictive. I don't necessarily see it like that. These are all individual strategies that have their own place. For example, you're not going to put in a predictive maintenance strategy for the light bulb inside your CNC machine, right? You're just going to change it when it needs done. So you have to be thinking holistically and making the best use of the best type of maintenance approach as you do it, but really thinking ahead about how you're going to use something like predictive maintenance, because of what customers saying, oh, we need to sort out all of our planned maintenance first, and then we'll start thinking predictive. And I'm saying, well, hang on, if you set up a planned maintenance strategy and then you implement predictive, you're going to maybe remove somewhere between 15, 20, 30% of those planned tasks, or at least extend them. So think holistically, have a longer term vision, but do it incrementally. It doesn't need to be a big bang approach, but keep an eye on the target as to where you want to get to.
My response whenever I talk to people who say that is, do you diligently change your tyres in your car every year, regardless of the state of wear? Or do you measure the tread depth and then change your tyre? That's predictive maintenance.
Exactly.
It's no more complicated than that. So next question from the audience. In case the microphone didn't pick that up, good afternoon, Dennis. Good of you to join the call. It was one of the panel members' experiences of AI and what are their plans for the future?
Yeah, so our plans continue to grow our models as we go on a journey to obviously a Bentley future, a dream factory future. We will start baking in some of the sensing technology that we retrofitted to some of our existing infrastructure. And then we are looking obviously at the Gen AI solutions. So how can we take away an awful lot of this, having to delve deep into files to go back and look at problems that we've had previously. Remembering, of course, that, out of maybe 5,000 assets across our site, we might only touch one of those assets once every 8 years.
Yeah.
So it's important that when we capture that information, can we extract it and find it again in the future? We're vested in it. I think, continuing to do these little proof of concepts here and there just to make sure things work. But yeah, in terms of us, it's the Gen AI now for the future.
Agajan?
Yeah, we, as I mentioned before, like general LLMs and VLMs are more generic. And our goal in Robominder to teach these LLMs, VLMs be more manufacturing specific. Teach like manufacturing best practices, maintaining and best practices by feeding like video data, manuals, and other things. So in the future, hopefully it becomes good manufacturing AI.
Yeah, excellent. Rob, anything to add?
Yeah, I mean, I think Sensei's what Sensei predicted maintenance. But we're starting to look at how you actually pull that down. Like we were talking about a minute ago about reactive and planned maintenance. How can you be a more generalized maintenance assistant? And now that we've captured all of this information about how people fix things in the past, you can start to support reactive activities as well. So that's us. We feel we've kind of done the hard end of it, and now we're like down the scale and extending it out wider. So it's your more general maintenance assistant is the way that we're thinking about this now, and not necessarily always having your reliance purely on type series sensor data. Thinking about how can you build out from these documents and maintenance records and human transactional data is the way it's going now.
Cool, thank you. Good afternoon, James. This is about skills development. So I'll start again with you, Jonathan.
Yeah. So how do we grow that? I think skill set, and how do we make sure it's standardized? I think was the question. It's there are kind of courses. There are people now looking at this as part of future education. But I don't think at this stage there is anything that is predefined as being this is the digital training course that you would need to go on, particularly as, say, a maintenance operative. And I think the reason for that is it's still incredibly new. It sometimes takes a long time for that kind of understanding and that training to actually hit that kind of level, that operational level. And I think a lot of it is going to have to be done by some of the kind of the halo companies, the people that are the early adopters of this tech. There are nevertheless a myriad of companies and think tanks that you can go to educate yourself and educate your team. But in terms of the practitioner side of actually delivering, it depends what you buy and it depends what you implement.
I think for me, some of the challenges are actually that some of the underpinning principles of maintenance are still not as widely understood as you would like to wish. We've all known how to maintain, assets since the 70s and 80s when all the fundamental research was done into, Nolan heap and the failure curves and, reliability centered maintenance. But actually, even now, 50 years on from, or nearly 50 years on from the publication of RCM, it's still not there with everybody. So for me, actually, there's a corresponding teaching of the fundamentals of maintenance, alongside, how to use AI as an accelerator against those fundamentals. Anything, Rob, Agajan, anything to add?
I'd say within Siemens there's kind of two levels. Working closely in enabling the technology to be accessible by sort of academic institutes, so doing work with universities is key. But then also having our own training portals for end customers that can come in and train on a wide variety of things, right from industrial IoT right through to analytics, and making that accessible and democratizing it. But like you say, we're quite away from having sort of standard syllabuses in this area.
Yeah, I think we can probably start incrementally and start looking at the adjacent fields. For example, Gen AI, specifically LLMs, are very, very good at coding. So we use also a lot of PLC coding in manufacturing. So we can probably start adopting those practices in PLC code analysis or PLC code development, which will basically reduce our coding time.
Excellent, thank you. Well, that's all the questions we've had from the audience. So thank you very much for joining us. I'll do a final plug for those of you who've not had a chance to do so to download the Performance in Focus reports, and fantastic insight there from the hundreds of engineers who've taken the time to feedback on the report. Hope to see you. Well, thank you to Jonathan, Rob and Agajan for an interesting and informative conversation, and look forward to talking to you again at a future event.